So hello friends, in this video we are going to see the topic differentiation, basic formulas, used to find the derivatives of the function, which represents instantaneous rate of change. Okay, if y is a function of x, then differentiating y with respect to x on both sides d by dx of y equal to d by dx of function of x. So we have taken the differentiating derivative on both sides. Okay, so now we are going to see the formulas for derivatives. So x raised to n, nx raised to n minus 1. So this is the basic one which we will be using. Example, x raised to 2, then 2x raised to 2 minus 1. 2 minus 1 is 1. So x raised to 1 is, you can write it 2x. Okay, so x cube, then again the same formula, nx raised to n minus 1, 3x, 3 minus 1 is 2, 3x square. Okay, so these are the derivatives. So if it is y equal to root x, then again putting the derivative on both sides, you can get this, you can convert it the root to raised to power half, and then you can put the same formula x raised to n, which is nx raised to n minus 1. So n is half, x raised to n minus 1, half minus 1. Then here you have to do the cross multiplication. So 1 by 2 minus 1 upon 1. So here cross multiply, 2 goes there and it is minus 1 by 2 x raised to, which we can also put it like 1 by 2 upon root x. Okay, so this is the derivative. D by dx, you have to write everywhere. So now derivative of x raised to 1 upon x, which is, we can write it taking it in up, x raised to minus 1. So now here you can also apply the same formula, nx raised to n minus 1, which is n minus 1, x raised to n minus 1. So minus 1 minus 1 minus 2, so which is minus 1 into x raised to minus 2. You can also write this 1 upon x square minus 1 upon x square. Okay, d by dx of 1 upon x is this. Okay, so derivative of log x, the formula is 1 by x. This will also be used further. So derivative of sin x cos x first, second derivative of cos x minus sin x, third derivative of tan x sec square x, fourth derivative of cot x minus cosec square x, derivative of sec x into tan x, derivative of cosec x minus cosec x into cot x. 4, 5, 6. Derivative of constant is 0. Okay, so with the help of these formulas we are going to solve the problems further. So let's start. So let y equal to sin x. So differentiating y with respect to x on both sides, d by dx of y equal to d by dx of sin x. Okay, so d by dx sin x. So now we know that derivative of sin x is cos x, so directly put cos x. So this is the answer. Okay, so now next question, y equal to sin x plus 9. So now what we are going to do is differentiating y with respect to x on both sides, d by dx of y equal to d by dx of sin x plus 9. We have to consider it as x, okay, as we have the formula. So here you can see derivative of sin x is cos x. Consider this whole term x plus 9, right as it is cos x into derivative of which we have considered the x, this part x plus 9. Okay, so now write this term as it is cos x plus 9 into as it is into derivative of this. So derivative will go to both x also and then, so derivative of x plus derivative of 9. Okay, and put the bracket. So derivative of x is 1, derivative of constant is 0. Okay, equal to cos x plus 9 as it is, and this is whole term into bracket. So cos x plus 9, this is the answer. So put the bracket everywhere to avoid the confusions. This goes to both. Okay, so this is the answer. So now next question, if y equal to log x, then derivative d by dx of y, differentiating y with respect to x on both sides, derivative of log x is 1 by x. Okay, we have the formula. Then let y equal to, we are going to take the example related to this, sin x plus 2. Okay, so now consider this whole thing as x. Then we have the formula log x is 1 by x. So just we are going to do this, differentiating y with respect to x on both sides. So d by dx of y equal to log x is 1 by x. Okay, so 1 by x, we have to consider this sin x plus 2, 1 by x into differentiating what we have considered as x, that is sin x plus 2, the whole term, it is in bracket. Now we have to differentiate this. The first thing we have to just write as it is sin x plus 2. So derivative of sin x plus 2, so consider this x plus 2 as x, because we have the formula of sin x is cos x. So derivative of sin x is cos x, but we have to write this, what x plus 2 into derivative of what we have considered x, that is x plus 2. Okay, so now this part is, again we have to just write this whole part front as it is, that is cos x plus 2 upon sine x plus 2. Okay, now we have to see this derivative of x plus 2. So derivative goes to both. Derivative of x is 1 and derivative of constant is 0. So derivative of x plus derivative of 2. So now derivative of constant is 0, derivative of x is 1. The bracket is important to avoid the confusion. So now this goes to both. The same thing we have to write as it is, cos upon sine. So now we can simplify this with the help of trigonometry basic. O A O A. Keep this simple things for your basic. Sin theta opposite upon hypotenuse, adjacent side upon hypotenuse cos theta, and tan theta which is OA opposite upon adjacent. Okay, so sin upon cos is tan theta, cot theta is cos upon sine, cos theta upon sine theta. Okay, so with the help of this formula we are going to put there cos x plus 2 upon sine x plus 2. We have it, right? The x remains the same, the theta remains the same, so we are going to put this in here, cot theta which is x plus 2 into 1 was same. Okay, that was the answer. So next question, y equal to sine square x plus 2. So now here we have to consider differentiating y with respect to x on both sides. Derivative d by dx of y equal to d by dx of, consider this whole term as x raised to 2. Okay, yeah. So now sine x plus 2 square. So considering this whole term as x, so derivative of x raised to n and x raised to n minus 1. This is the basic formula, right? So we are going to implement this formula here. So 2 which is n, x is the our sine x plus 2 raised to n minus 1. N is 2, 2 minus 1 is 1. You have to write it in the next step by step, then only you will get the marks. Okay, so I am doing it roughly. So into derivative of which you have considered as x, that is sine x plus 2. So in the next step you have to derivate this. The rest part you have to keep it as it is. 2 sine x plus 2 into derivative of now sine x plus 2. So we have the formula sine x, derivative of sine x is cos x. So get cos x which is x plus 2 into derivative of which we have considered x. Okay, so now next step you have to derivate that, and you have to write this all as it is. Now 2 sine x plus 2 into cos x plus 2 as it is. So derivative of x is 1 and derivative of constant is 0. So 1 plus 0 bracket is important to avoid the confusion. So in the next step it goes to both. So when you multiply this you get the same into 1. So 2 sine x plus 2 into cos x plus 2. Okay, so now if you see this you can also simplify further, as we have this formula is sine 2a equal to 2 sine a into cos a. So this formula we are going to use it standard formula here. So as you can see, 2 sine a is x plus 2, cos a is x plus 2. So here we can put this 2 x plus 2. So it has been further simplified. So further you can write it like this, 2x plus 4. So now next question, y equal to under root sine x. So consider this as x. So now we have the derivative of x raised to n formula. So nx raised to n minus 1, right? So derivative of root x is 1 by 2 root x. The basic formula we have it. So we are going to apply it directly here. Differentiating y with respect to x on both sides. So derivative d by dx of y equal to d by dx of under root sine x. So now derivative of root x is 1 by 2 root x. So x is sine x into which we have considered x derivative of sine x. So in the next step we have to write the first thing as it is, 1 upon 2 root sine x into derivative of sine x is cos x. Okay, so this is the answer. So cos x upon 2 root sine x. So now next, y equal to cube root x raised to square. So here you can use this formula, which is a raised to m raised to n equal to a raised to n raised to m equal to a raised to m into n. Okay, so now here also we are going to do the same, taking the derivative on both sides, differentiating y with respect to x on both sides. So here you can write the cube root as x raised to power 1 by 3. So this x raised to 2 by 3. So now here I can put this formula x raised to n, which is nx raised to n minus 1. Okay, so derivative of x raised to n is nx raised to n minus 1. So this formula we are going to apply here. So n is 2 by 3, x raised to n minus 1. So here you have to do the cross multiplication. 3 goes here. So 2 minus 3 is minus 1 upon 3. So here you can write x raised to minus 3. 1 minus 3. 2 by 3. X raised to 1 upon x raised to 1 minus 1 upon 3. So it goes in the denominator. Okay. There you will put the cube root. 2 by 3 into cube root of x. This is in the multiplication. 2 by 3 into cube root of x. So this is the answer. Differentiation equation in real life examples are like physics, engineering, biology. In physics, example, motion of object, then heat transfer, then fluid dynamics, then in electrical circuit. So these are the basics in which we can see in motion of an object, the projectile motion and the pendulum calculations. So these are the basics where it will be applied, and for further you can just go through the description. I have mentioned the in detail from the net. Okay, so you can, if you are interested in the theoretical part, you can go through that. So that's all. Thank you.